So in this 3.1 assignment, there is a method for finding lowest common multiple, and this is one way, obviously, where you times 1, times 2, times 3, times 4. Just do a list, and then the lowest common to all the lists, that's the multiple, that's the LCM. But if you have 3 and if you have large numbers, there is a quicker way to do it, but it involves prime factorization. So what you're going to want to do first, to find the lowest common multiple of any 3 numbers or more, you find the prime factors. So we'll do that real quick. So once you have your list of prime factors, okay, now the greatest common factor and the lowest common multiple are very different, right? So if you look on page 138 there, it says this: do the prime factorization, and then it says this, and I'm going to write this out here for you. You want to highlight the greatest power of each prime factor in any list. So for 15, we have 3 times 5. For 32, we have 2 to the power of 5. And for 44, we have 2 squared times 11. So what this is saying, highlight the greatest power of each prime factor in any of the lists. So this is what you do, and this is the tricky part, so listen carefully. The prime factors, starting from the lowest one, is 2. We don't have any 2's here. We have 2 to the power of 5 here, and we have 2 to the power of 2 here. So in any of these lists, so really this is 2 to the power of 0, right, because it's not there. So which is the largest power of 2 of these 3? Yes, the 2 to the power of 5. So you highlight that one. Let's do that. What about 3? Well, is there a 3? There's a 3 here, and it's the only place that 3 shows up. So guess what? I'm going to highlight this one. And what's another one? 5, okay? I've got a 5 here. I don't have 5s anywhere else. So guess what? Got to highlight that one. You getting this pattern here? Okay? You understand how this is going? And then, of course, 11. We only have one 11. And so this is the largest, the largest power is just 11 to the 1. So once we've done this, so that's highlight the greatest power of each prime factor in any of the lists. So again, 2 shows up twice here, but this is the highest one. So then what you do is you multiply those together. So multiply out the highlighted powers. So I've got 3, I've got 5, I've got 2 to the power of 5, I've got 11. See, those are the ones that we highlighted. If you multiply all those out, what do you get? 5,280 of these 3 numbers. And yes, it would take you a very long time to write out the list of multiples, right? 15 times 1, 15 times 2, 15 times 3. Yeah, very long time. You can fill up your whole notebook doing some of these questions. So this is the method here using using the greatest powers of any prime factor in any of the lists. And you multiply them together.